All right, so this objective is 11.1D. So we're finishing up the law of sines here today. The topic today is finding the area of triangles using trig. Particularly, we'll be using the law of sines. And we'll also be using the angle sum theorem for triangles. And our goal, if we're going to find area of triangles, we need to have the information side angle side in conjunction with the formula I'm about to give you to find the area of a triangle. So if you recall, back in geometry, you were given the formula: the area of a triangle is equal to 1/2 the base times the height, or base times height divided by 2. Okay, and that's really useful if you have the height measurement and you have the base measurement. But in the triangles that I'm presenting to you today, we don't have either of these measurements. And so we have an alternative formula that says this: the area of a triangle is equal to 1/2 side A times side B times the sine of sine C, or, well, it depends if you have side A and B. So this is an example of side angle side, or it could be 1/2 of B times C and then the sine of A, or it could be 1/2 of A times C and then times the sine of B. And it's just really critical. We can use this formula if we have side angle side. So I'm going to draw a picture here of a triangle. And this is triangle A, B, C. So here's side A, here's side B, and here's side C. So if we have this information here, like we have side angle side, then we can use this formula, and we would just choose in this situation the third formula, because we have side A and side C, and then we have the angle that's included between them, which is angle B, and that would be considered side angle side. Okay, so here's example A. Find the area of the triangle to the nearest tenth. And we're given angle B is 42 degrees, side A is 7.2 feet, and side C is 3.4 feet. So let's see what that looks like. Here's angle B at 42 degrees. So that means side B is over here opposite. And so we'll make this angle A and this angle C. So this will be side A at 7.2 feet, and this will be side C at 3.4 feet. And I'm not sure what I wrote C. I'll just clean that up real quick. 3.4 feet. Okay, and so in order to solve these triangles, we need side angle side. And if you'll notice here, that's exactly what we have, side angle side. So we could say, okay, so the area is 1/2 of side A times side C times the sine of angle B. And I'll take you back up here to see that that's actually that angle, or that formula right there. So we'll go ahead and plug that in. 1/2 times 7.2 feet times 3.4 feet times the sine of 42 degrees. And we'll plug that into the calculator. Let me grab my calculator real quick. So 0.5 times 7.2 times 3.4 times the sine 42. Please remember to put your calculator in degrees, and we get 8.19. So, excuse me, feet squared. So the area to the nearest tenth would be 8.2 square feet. Let's take a look at the next problem here. It says we have x is equal to 74 degrees, y is equal to 63 degrees, and z is equal to 5.9 yards. So we have two angles and a side. That's definitely not side angle side, so let's draw a depiction. So here we have angle x. Sorry, sorry about that, which is 74 degrees. And angle Y, which is 63 degrees, so I'm going to put that over here. And side Z. So this would be angle Z, so side Z would be here at 5.9 yards. Okay, so here's what we have here. We have an example of angle, side, angle, and what we want is side, angle, side. So if we could just get this measure right here, then we could have side, angle, side. So and I think we can find X if we do something first. If you'll notice, I'm going to just erase this for a second. If you'll notice, I have one measure for each pair of letters on my triangle. I have half of X, I have half of Y, and I have half of Z. But if I just had all of Z, if I just had that angle measure there, then I could use angle Z and side Z and the law of sines to find side X. So I'm going to do my intermediate steps in red. So first what I'm going to do is find angle Z by using the angle sum theorem. So Z is equal to 180 minus 74 minus 63. And we plug that into our calculator and we get a measure of 43 degrees. Okay, so I'm going to fill that in at 43 degrees. All right, so now I feel like we have enough information here to go ahead and find side X, because that's what I really want to know. What is X? If I could find that, then I could find the area using the formula. So I'm going to go ahead and do X over the sine of 74, using my law of sines here, over Z, because I have this full piece of information here, 5.9 over the sine of 43, and then I'll multiply both sides times the sine of 74, so times sine of 74, so I can cancel that and plug that into the calculator, and I'm going to approximate just to the nearest tenth, plug that in, and so we get 5 sine. That would be approximately 7.7 units. So I could come back up here and say, all right, so X is 7.7 units. Now I have, and I'm going to grab my blue pen, I have side, angle, side. And because I have side, angle, side in blue here, I can now use my formula that says, I'll do it in blue here, the area of triangle XYZ would be, we're going to do Z times X times the sine of Y. There's my side, angle, side. So we'll just substitute in here. Z is 5.9. Oh, wait, we need a 1/2 here. Let's clean that up. 1/2 of Z times X times the sine of Y. All right, so substituting in now. So we get 1/2 of 5.9 times 7.7 times the sine of 63, and we plug that into the calculator and we get I should put yards in here. Let's see, 21.8 yards squared, or square yards, and so that would be the area of that triangle there. So remember, to use this formula, you have to have side, angle, side, and when you're not presented with side, angle, side, you have to do what you can using your angle sum theorem and the law of sines to help you get to the information side, angle, side, so you can use the formula. Let's take a look at C. All right, so C is an obtuse angle. It has an obtuse angle here, and this should be a capital Z, and I believe on your note page I did make that correction. So there's capital Z there. All right, so I'm going to do that black. So as our given information, we have 2 sides and an angle. However, I don't believe this angle is between the 2 sides, so I'm going to draw an obtuse triangle here, an obtuse angle for angle Z, because it says that it's obtuse. So there's Z, and there's 117 degrees. And so side Z would be over here at 12.7 inches. And so we'll say that this is Y. So this would be side Y right here, which is 4. And then they didn't even tell us what the other part of the triangle's, the last letter is. So I'm just going to call it X. Okay, so there's our given information. And we want side, angle, side. So let's see what we have here. We have two sides, here and here. So if we could get this included angle right here between them, then we'd have side, angle, side. So I'd really like to find angle X. But here's the thing. I don't know anything about, sorry about that, I don't know anything about side X, so that's not useful. I do have a full pair here. I have side Z, an angle Z, I have that, and I have half of Y, I have side Y. So the only thing I can do at this point is use the law of sines to find angle Y, which then in turn, if I know angle Y, then I can find angle X. So I would use, here's my intermediate step here, I would use the sine of Y over side Y equals the sine of Z, so the sine of 117 degrees over 12.7 inches. And so I would do a little math there, multiply both sides times 4, so I'm just going to move that up there, cross multiply. So we get sine of Y equals 4 sine 117 divided by 12.7, and then we're going to have to take the inverse to find the angle Y here. This is a big Y, so we'll do sine inverse of this value here for sine. And then if we get like a domain error, then this doesn't make a triangle, but in this case today it does make a triangle. Remember, when you have side angle, you always have to be careful about whether or not you're going to get a solution. This is going to give us a solution. So we're going to do sine inverse. I'm just plugging that into my calculator here. So I'm getting the measure of approximately 16.3 degrees. And so that is the measure for angle Y. So I'm just going to slide that in there, 16.3 degrees. Okay, perfect. So now remind yourself, we're trying to get side, angle, side. So we really do need angle X. And to find angle X, that'd be simple. We'll just take 180 minus 117 minus 16.3, plug that into our calculator, and we get 46.7 degrees. So I'm going to grab my my blue pen here and just put a little measure here of 46.7 degrees. So now we have side, angle, side. So we can find the area of this triangle. All right, and so we would do 1/2 of side Y times side Z times the sine of angle X. So that's 1/2 of 4 inches times 12.7 inches times the sine of 46.7, and we'll plug that into the calculator and we'll round it to the nearest tenth. And this is in inches, and so we're going to get approximately 18.5 inches squared. And so there's the area of that triangle. So again, remember, your goal is to get to the information side, angle, side, so that you can use the formula to find the area. Last one here. So here I'm giving you two angles, angle A and angle B, and side A. So this is going to be angle, angle, side. Probably. So let's draw a picture of that. Grab my black pen here. So angle A is obtuse, 103 degrees. Oops, putting it in the wrong spot there. Angle A is 103 degrees, and angle B, we'll just put it here as about 38 degrees, and side A over here is 14.7 feet. Okay, so this is definitely angle, angle, side, and what we want is side, angle, side. So let's take a look at this. So maybe since we have this side here, I mean, there's a number of things we could do. We could just go ahead and find this side, and then we would have side, angle, side. We would have side, angle, side. So I guess we'll go ahead and call this side angle C, and we'll call this side C right here. So we need to find side C. Well, to do that, we really need to know what angle C is, because we have A, we have the pair of A's, but we don't have either part of C, but it's pretty easy to find C when we already have angle A and B. So we'll start with angle C, which is equal to 180 minus 103 minus 38, and that would give us the measure, hang on a second, $39. And I believe that my example D and example C are switched, so sorry about that. Hopefully you picked up on that pretty quickly. All right, so that's 39 degrees, and so I should have done that in red. That's my intermediate step. So there's 39 degrees. So now that I have angle C, I can find side C, which is what I'm looking for. So to find side C, I would do C over the sine of C. And then I would use my information for A, side A, because I have both pieces of information there, over 103 degrees. Multiply both sides times sine of 39 to clear the fraction. So we'll go times sine of 39. Just multiply, cross multiply there. All right, and so we get approximately, plugging that into the calculator, approximately 9.5 feet. And so that's the measure of this this side down here is 9.5 feet. And so now we do have side, angle, side, and we can find the area. So we have the area of triangle ABC is going to be equal to, I think we'll say A times side C times the sine of angle B, and we'll plug that in. So A is 14. Again, I forgot the half, so I'm going to squeeze that in there. 1/2. Sorry about that. 1/2 of A, which is 14.7 feet, times C, which is 9.5 feet, times sine of B, so sine of 38 degrees. And we plug that in to our calculator. I'm just double checking here. 9.5, 38, approximately 43.0, and that would be feet squared. And so that would be the area of angle on the problem D, the area of triangle ABC. Okay, so there's some examples of taking some given information and spending time finding inputs for side, angle, side, and then using the formula to find area. Last example here is a word problem here. It says find the area of a triangle garden. A university landscaping architecture department is designing a garden for a triangular area in a dormitory complex. Two sides of the garden formed by sidewalks in front of buildings A and B. Okay, so here's a sidewalk A and B, measure 172 feet and 186 feet respectively, so this would be building A, and 180, so that's 172 feet, and B, they together form a 53-degree angle. So I'm going to draw a 53-degree angle. So together these buildings, so here's would be building B right here, form a 53-degree angle. So that's the measure between them. And so building B has a sidewalk that's 186 feet long. Okay, the third side of the garden over here, formed by the sidewalk along Crossroads Avenue, measures 160 feet. What is the area of the garden? So we're looking for this space in here to the nearest foot. Well, if you notice here, I have side, angle, side. So we probably didn't really need that other side of the garden, but that's okay. So we're just going to go ahead and say the area of this garden will be 1/2 of 172 feet times 186 feet times the sine of 53 degrees. And we plug that into the calculator. And we get to the nearest square foot, 12,774.9. So we'll say 75 square feet. And that would be the solution to that problem. And there you go. That's finding area of a triangle when you don't have the height.